Doodle Physics. Hello and welcome to another video from Doodle Physics. In this video, we'll talk about scalar and vector quantities. Have you ever gone to a vegetable shop to buy some potatoes and you ask for 2 kilograms of potatoes and the shopkeeper asks you further question that where should I give you 2 kilograms of potatoes? No? Yes, we know. He did not ask you this invalid question because there is no relation of mass of potatoes and direction. In the same way, if you ask your friend to walk or run for 500 meters, then he will definitely ask you, where should I go? Yes, this time the question is valid. He is asking you for directions where to run or walk. The only difference between both of the scenarios is the direction, and due to the direction, scalars are different from vectors. As we discussed in our previous videos, that physics is the study of physical quantities, and physical quantities can be categorized as scalar and vector quantities. Scalar quantities are those quantities which need only magnitude to completely specify and no direction is required. Whereas vector quantities are those quantities which need magnitude as well as direction to completely specify. Before proceeding ahead, let us first understand what is magnitude. Magnitude consists of two parts. The first part is a number and second part is a complete unit. For example, 5 kilogram is a magnitude which consists of a number 5 and a proper unit kilogram. Hence, scalar quantities only require a number and a unit to completely specify, which we call magnitude. In addition to magnitude, vector quantities require direction for their complete specification. Let us give some examples of both scalar and vector quantities. Examples of scalar quantities are mass, time, density, area, volume, temperature. All these quantities do not require any direction to completely define. Whereas, examples of vector quantities are displacement, velocity, acceleration, force, torque. All these quantities require direction to completely define. So finally, we came to know that the one and only difference between scalars and vectors is direction. But this difference of direction causes solid impact on calculations and mathematics of vector quantities. Let's understand how. Suppose if we have two bags of sugar, one is of mass 5 kg and other is 4 kg. So we can add these two masses with normal mathematical operation and the result of 4 kg and 5 kg will be 9 kg. But in case of two forces acting on a body with 5 Newton and 4 Newton magnitude, then their resultant cannot be calculated using normal mathematical operations because force is a vector quantity, and as we learned that vectors depend upon direction. So, if the two forces are acting in the same direction, then their resultant will be 9 Newton. If they are acting in opposite direction, then their resultant will be 1 Newton. Or if they will act with different angles, then the resultant will be different. Hence, direction plays a vital role in mathematical operations of vectors. We will discuss more about vectors in our upcoming videos, so stay with us to make physics not boring anymore. This is the end of this video. If you like this video, then please hit like button, share this video and subscribe our channel. Thanks.